Good day, everyone. Here we go again. We're going to discuss properties of operations on integers. So our learning competency here is learner illustrates the different properties of operations on sets of integers. So what you need to understand here is that the properties of operations on integers. So in performing operations on integers, certain properties are being followed. These properties involve order, grouping, identities, and inverses. So let's take a look at here. So we have the closure property. So we have here the set A, then we have another emoticon there saying, why can't I come in? So the set A says that, sorry, we are closed set. We are a closed set. So we have here, the given set A are smileys, and the other one is, a rectangular figure there. So, Then another one, so as you have seen, as you can see rather in this example, if you're adding smiley, another smiley, and another smiley, then the answer is, of course, a smiley. Still smiling. Now, if your answer is a sad face, so that is not closed under closure property. So that's it. Next is commutative property. For commutative property, we have illustrations here that motorcycle riders plus bicycle riders. If you're going to change the order, we have bicycle riders plus motorcycle riders. They are just the same. Even though changing the order, wherein the motorcycle riders plus the bicycle riders is just the same when you change it to bicycle rider plus the motorcycle rider. And that property is commutative property. So even though changing the order, still the same. So, okay. Next, for associative property, this is changing groups. Regrouping. So the first group, we have a group of phones, cell phones, plus iPods, plus laptop. Then, it is also the same as when you group the iPod and laptop added to the cell phone. So, regrouping the items still the same, and that is associative property. So that is changing or regrouping, So regrouping. So another, we have distributive property. We have 6 oranges plus 12 apples. The result of this, when you add the 2, multiplied to 2, is just the same when you set 6 apples times 2 plus 12 apples times 2. They are just the same. Okay. So that is writing it. We have here 2 times the quantity 6 oranges plus 12 apples. It's just the same when you multiply 2 times 6 oranges plus 2 times 12 apples. That is distributive. That is applying distributive property. They're just the same. Next, we have here identity property. For the identity property, we have here an example: 2 apples plus empty or 0 is just the same as 2 apples. So that is identity property. Then here another one. When you put in, okay, when you put in something here and you put it out, what is left? 0. Nothing. So that is just the same when you put your A there inside, then you remove again A inside the box. Then the answer is always 0. Nothing left. So that is inverse property. Okay, similarly, the properties of the operational set of integers can also be applied to the operation. We have here an example. Closure property. For every A plus B, it is equals to C. That is for A plus B, it is equals to C. Like for example, 7 plus 2 equals, it should be 9. This should be 9. So, correction, this should be 9. So, 7 is an integer plus another integer. The answer is still an integer. Okay, it should be 9. So, please take note of that correction there. Okay, next. Commutative property for addition. There are two. We have commutative property for addition and commutative property for multiplication. For addition, here we have A plus B is equal to B plus A. So changing the order of the term is just the same. Okay, that is under addition. Commutative property for addition. So here, A comes first plus B is just equal to when B comes first plus A. So an example we have here, 2 plus 3, if you change the order, then you write first 3 plus 2. The answers are just the same. It is just the same. So, applying commutative property for addition. It is true for addition. Another we have here, it is also true that commutative property is also true for multiplication. For multiplication, we have A times B. If you change the order, is just equals to B times A. So the same as 2 times 3 is just the same as 3 times 2. Okay, that is changing order of the number. Next, we have associative property. For associative property, okay, it is also true for addition. Associative property is true for addition. So, this is regrouping. We have here A plus the group of B plus C, okay? A group of B plus C added to A is just equal to when you regroup A plus B plus C. Okay, so again, when the group B plus C added to A is just the same when you group A plus B plus C. So an example we have here, the group 3 plus 4 added to 2 is just the same when you write it 2, okay, when you regroup it as 2 plus 3, okay, plus 4. They are just the same. Anyways, this is 7. 7 plus 2 is 9. This is 5. 5 plus 4, still 9. So therefore, associative property is also true for addition. Associative property is also true for multiplication. We have here the group B times C multiplied to A is just the same when you group A times B times C. So an example we have here, the group 3 times 4 times 2 is just the same as when you group 2 times 3 times 4. They're just the same. Another we have here, the distributive property. Distributive property of multiplication over addition. So, if you have a group of B plus C multiplied to A, this can be also written as A times B plus A times C. So, an example we have here, a group of 3 plus 4 multiplied to 2 is or also can be written or equals to 2 times 3, okay, 2 times 3 plus 2 times 4. Okay, that's it. Another we have here, identity property for addition. Identity property for addition. Okay, so we have 0 is just identity property for addition. So we have A plus 0 is always equals to A. So any number A plus 0 is just equals to A. That is according to identity property for addition. So that is, we have an example here, 2 plus 0 equals 2. So any number plus 0 is just the same as the given number. It is also true for multiplication. We have A times 1. So the identity property for multiplication is 1. 1 is called the identity property for multiplication. So A times 1 is just equals to A. So whatever number multiplied to 1 is just the same as the given number. So we have here 2 times 1, of course, is just equals to 2. We have inverse property. For inverse property, we have here any number A plus the inverse of A is always equals to 0. So an example we have here 2. The inverse of 2 is, or the opposite rather of 2 is negative 2. Then opposite plus 2 plus the given, okay, is always equal to 0. A number plus its opposite is equal to 0. Another we have here for multiplication. The inverse of A is 1 over A, or we call that as the reciprocal of A. Okay, reciprocal of A, or the inverse of A. So A times its inverse is always equals to 1. So here we have here, the given is 2, the inverse is 1/2. 2 times 1/2 is always equals 1. For 0 property of multiplication, we have any number multiplied to 0 is always equal to 0. That's it. So you will just write the property here. If it is closure, if it is commutative property, if it is associative, if it's identity property, you will just write the property here. Okay. Next here, you will give the answer if you will apply distributive property. What should be this one equal to if you use the distributive property? And how do you write this if you will use associative property? Another, how will you write this one if you use commutative property? The same with the rest, applying these properties. Okay, again, we have here the key points. Properties of operations on set of integers. We have here closure property. Two integers that are added and multiplied remain as integers. So the set of integers is closed under addition and multiplication. If you add integers, then the answer is integers. If you multiply integers, then the answer is integers. It's an integer. Commutative property. Changing the order of two integers that are either being added or multiplied does not change the value. So meaning, if you add these two, even though you will change the position or the order, in multiplication and addition, the value remain the same. So for associative property, changing the grouping of integers that are either being added or multiplied does not change its value. So regrouping, this group added to, for example, to another one, and you will change the order. So it is either being added or multiplied, it will never change the value. So that is for associative. For distributive property, when two integers have been added or subtracted and multiplied by a factor, the result will be the same when each integer is multiplied by factor in the product that are then added or subtracted. So for identity property, we have additive identity states that the sum of any integer and zero. Sum of any integer and zero is the given integer, meaning 2 plus 0 is just 2. Therefore, 0 is called the additive identity. For multiplicative identity, states that the product of any integer and 1 is the given integer. So, like for example, a times 1 is a, and 1 there is called the multiplicative identity. Next, we have inverse property. For the inverse property, we have, in addition, it states that the sum of any integer and its additive inverse is 0. So the additive inverse of a is negative a. The additive inverse of a is negative a. Additive inverse of 9 is negative 9. Additive inverse of negative 9 is 9. So it's always the opposite of the given number or integer. So therefore here, the additive inverse of a is negative a. Negative a is called the additive inverse of a. When you add the two, a and its additive inverse, the answer or the sum is always 0. In multiplication, states that the product of any integer and its multiplicative inverse or reciprocal is 1. So if given a, the multiplicative inverse of a is 1 over a. Multiplying a and its multiplicative inverse, the answer is always equals to 1. 1 over a is called the multiplicative inverse of a. Zero property of multiplication, when an integer is multiplied to 0, then the product is always 0. So any number multiplied to 0 is 0. That's it for today. Thank you for watching. Have a nice day ahead.